number 13, magnetic effects of electric current. So today I am here with you with the topic that is magnetic field direction of the magnetic field. In the previous video might you have seen that we have discussed about whenever a current carrying conductor is provided to you, or I can say that a metallic wire, it carries the electric current. So it is the rule, it's a law that it is going to produce magnetic field around it. So here onwards we are having the same topic further on explanation, that today we have to identify that what is the direction of that magnetic field which is produced when a current carrying conductor is provided between the electric circuit. So here rough diagram of electric circuit I have just shown. So let me discuss about it. Here very first I have just provided with the plug key. We have taken a battery connection, that is positive to negative terminal. Individually means 3 batteries I have just connected in a series that provides 6 volt of power. So that means all over the current is going to start the journey into the electric circuit. The plug key is on. So afterwards here the ammeter is provided which measures the amount of current which flows to the circuit. Now what I have just adjust between the terminal X and Y, I am just going to establish and connect over here a magnetic compass. Everybody is knowing that the work of magnetic compass, that always pointing out north and south direction. Wherever the geometric north of earth is there, that points extreme north and extreme south, we are just going to put the compass so it shows this kind of direction. So today we will see that what are the changes of the direction of the needle of magnetic compass will come when the electric current will flow through the circuit. So how is this electric circuit works, that we will see in the detail. Further on, I have just provided over here a direction analyzer. That means here onwards we can just take the help of this north, south, east and west direction, and we can take the help of it and we can just apply over the circuit, and we can conclude that what is the direction of the current in the circuit, and as a result of which what is the direction of the magnetic field. Okay, so very first we will discuss about the first diagram. The same mirror image of the same diagram I just placed over here, so that we will discuss afterwards. So let me go with this diagram first. As I just told you that whenever the plug key will be on, so battery will start providing the current from positive terminal to negative terminal. In short, I can say that current is moving in clockwise direction. If we just talk about the direction analyzer, so here I can say that the current is flowing from south to north. Okay, so whenever the current will start passing through the entire circuit, so here I have just applied a copper wire between X and Y terminal, and in between this terminal I have just placed a compass. And we just know that whenever a current carrying wire is provided into the circuit, so it is going to produce magnetic field around it. So as a result of this, you can imagine that magnetic field must has been created over here. So what will the change and what will the difference come? So afterwards, on and on, maybe 1 or 2 minutes within a time period, we can see that the magnetic compass needle will show the deflection. You all are knowing that whenever you are just putting the magnetic needle, it will be point out towards extreme north and extreme south. But here whenever it will comes in contact with the magnetic field, it shows a deflection. It will twist, it will turn. So our main concern is we have to see in which direction this magnetic needle has been changed. That is the only direction and that is the only way we can conclude and we can identify that this is what the direction of magnetic field lines. Okay, so magnetic field, magnetic compass, whenever it is placed in between the magnetic field, so it is going to turn towards the right hand side. So our conclusion is whenever into the circuit, whenever you just put the plug key on, and if you provide the current into the clockwise direction, otherwise you can say whenever the current is flowing from south to north direction, then the magnetic field will be created around the current carrying conductor, that is produces magnetic field, and the magnetic compass that point out towards, or it will show the deflection towards the right hand side. So here we can notify the direction of the magnetic field. So magnetic field must be produces into the clockwise direction in this way. So here is the current carrying conductor. So we can imagine that the magnetic field lines has been created into the circular direction around this X and Y terminal. Okay, so this is what the explanation for this diagram. Suppose the same thing I have just taken with the second number circuit. So here let me just denote that plug key is taken. Same amount of battery is connected over here with the same 6 volt. Ammeter is placed and same analyzer of the direction, that is we have just placed over here. Now only the difference is, everyone, the battery which is connected in the series that I have just inverted. That means here I have just applied negative terminal and here I have applied positive terminal. So current will flow into the anti-clockwise direction. Otherwise you can also describe the direction of the current flow, that is from south to north, you can see. Okay, so if we just provide the direction of the current from south to north or maybe into the anti-clockwise direction, so once again in between the conductor, means these are the two terminals as we have discussed, X and Y, and this is what your copper wire between which we have just placed a magnetic compass. So your copper wire that is working as a magnetic, that is working as a current carrying conductor which produces magnetic field around it. So if we notify, if we want to find out, if we want to discover what is the direction of magnetic field line of force, so your compass will point out or it will twist or it will deflect towards the left hand side. So the direction will change. So we can conclude that here the direction is anti-clockwise. So the deflection of the needle that will turn towards the left hand side. If the direction of flow of electric current is into the clockwise, so the deflection of magnetic needle that will be towards the right hand side, opposite to each other. You have to notify, you have to remember one point, that here the battery is connected in this way, means positive to positive, negative to negative terminal. Okay, and the current is moving in clockwise direction. And over here in this circuit, we have just put the battery that is in inverted situation. So it will be connected negative to negative first and current is moving into the anti-clockwise direction. So here the magnetic needle that shows the deflection in this way. One more thing is there, I just want to draw your attention that if you just use the magnetic compass, that is the only device which helps us to identify if the magnetic field is produced or not. So if you just keep the magnetic compass nearby the conductor, that shows maximum deflection. If you put your compass away from the magnetic field or little bit farther from the magnetic field, so it shows gradually decrement into the deflection. So more the deflection, if stronger the magnetic field. When we can produce the stronger magnetic field? If you provide more amount of current. So these are all connected with the chain, like provide more amount of current, that gives you more amount of strong power of magnetic field. So strong magnetic field is created, that shows maximum deflection of this magnetic compass. So now we will discuss my next point is, my next topic of the chapter, that is right hand thumb rule, everyone. So let's discuss about in detail that how this right hand thumb rule is useful in terms of electricity, in terms of magnetic field and in terms of physics. So this chapter second point is right hand thumb rule. So I just want to show you something, everyone. Just look at have a look here. So if I have hold this marker in this way, okay, and my thumb is pointing towards the upward direction. So my thumb that shows the direction of flow of electric current. So if I just connect this thumb with the electric circuit, so you can say and you can find that right now the direction of current is in the upward way. So means upward side the current will move and then afterwards it will be connected further on. So during this time, the magnetic field which is created around the current carrying conductor, that is in the direction in which the fingers are wrapped. The fingers are just wrapped into anti-clockwise direction around this. So whatever the direction of your fingers are there, that's what the direction of your magnetic field. So that is what the right hand thumb rule describe for electricity and for magnetic field. So once again, let me tell you, suppose I just hold the thumb in this way. So the pointing out direction of the thumb, that shows the direction of motion of electric current. So right now the electric current is emerges out in the upward direction. So whenever this phenomena occurs, so during that time the magnetic field which is created around the conductor, that is how my fingers are going to wrap. So fingers are just with respect to my thumb that wraps into anti-clockwise circular direction. So this is the direction of the magnetic field we can conclude with. Okay. Now reverse of it. Suppose I just show my thumb that is just going to show downward direction. This means I am just putting the thumb upside down. So here the direction of electric current, that is in the downward direction. So during that time the magnetic field will be going into the clockwise way. So this is what the direction of the magnetic field we can discuss. Okay, so that depends, means here whenever you have to remember only two things everybody. The thumb that shows the direction of motion of electric current, and with respect to the thumb, wherever you are just going to twist your fingers, that is the direction of motion of magnetic field. So this is how the right hand thumb rule work. As one more point which is related with this, I also want to conclude here. That is the one more rule is there, that is Maxwell's corkscrew rule. So this Maxwell's corkscrew rule and right hand thumb rule, they both are similar to this type, because in Maxwell's corkscrew rule he has just taken a screw and he is just going to point it and he drive the screw into inside the wall. So the direction of the screw, that means the screw is going to move inward side. So that is showing the direction of current. And with respect to that, we have to drive the screw into the circular motion. So the direction of the circular motion of that screw, that provides the direction of the magnetic field. If you just drag the screw outside, so you have to twist this screwdriver into opposite direction. So that is the direction of the magnetic field. But as a result of that, during that time, the screw is going to come out. That means the direction of current, electric current, that is in opposite direction. That is just going to emerge out of the wall. So Maxwell's corkscrew rule as well as your right hand thumb rule, both are of similar type. So here everyone, our next topic, that is magnetic field which is generated into the circuit due to the current through a circular loop, that we have to discuss. Now previous topic what we have studied, if you are just provided with a kind of metallic wire and if you provide electric current, so it must produces magnetic field around it. Now what this topic is saying, just take the same wire but just bend it and make a circular loop and connect it with the battery with its two end points. So that's what the diagram here is. This is what your loop, okay, your metallic wire that has been bended in a circular way, and then remaining two points I have just attached with the battery. So whenever I just put the key on, whenever I will start providing electric current, so electric current will flow into the clockwise direction. You can see that from here onwards the electric current will start flowing and afterwards it reaches back to the negative terminal. So like how only we can say this is what your electric circuit path, and electricity is flowing in this direction. Okay, so as soon as you just provide the current in a metallic wire, so you can see certain lines I have just drawn over here, that is actually showing you how and what is the direction of magnetic field line of force. So these lines are nothing but these lines are only the lines of magnetic field line of force. So here around the magnetic, here around the loop, you can say that the magnetic field has been generated. And this magnetic field is generated, and that is only because of the magnetic field line of force. Now further on in detail analysis, if you just have a look over the loop, so at individual point, the points are just over here only. So individual point you can see and you can consider that at every point, that point is working as a center, and around the center the magnetic field line of force is created in a elliptical circular path. So here you can see that if I take this point of a loop and current is passes over here, so it is just created a magnetic field in a circular elliptical way. So concentric circle of magnetic field line of force has been generated. So like that only you can see that further on, if you move move on individual all the points of the loop, so more number of that circular concentric circular line of magnetic field force that is been generated. So at every individual point throughout the loop, this kind of circular path of that magnetic field line of force that has been created. But what afterwards? As you just move towards the center part of the loop, so distance from the loop to the center, that is increases. So there is one sentence everyone that you have to focus on. As the distance increases, the effect of magnetic field line of force that decreases. So more number of gapping between the electric field line of force that has been generated. So you can see here, if the magnetic field force lines, they are more close to the loop, so they are just forming nice a small concentric circle. But if the distance is greater, if gradually the distance has been increased, so it changed the shape. So you can see the line of forces over here are in the form of an arc. So here also you can see the arc is that is shown in the diagram. So now just focus. This is what the pattern of the magnetic field line of force, everyone. This is what we can say, that the pattern into the group, into the all the your electric loop, how the patterns of magnetic field line of force is created. Next thing is what, if you just focus at the center of the loop, so all the magnetic field line of force that will pass through the center on a straight path. They will not show any kind of electrical any concentric circle. They will also not show any kind of arc. Only the magnetic field line of force from the center that moves into the straight path, where only when we are having the center of the loop. Okay, so that's what the direction, and that's what we can conclude, that if we have the electric conductor, but if we just bend it into the circular path and if we provide electric current, so current that must produces magnetic field. But what is the pattern of the magnetic field line of force? That is over here nicely shown. If you are having the lesser distance from the wire, so magnetic field lines will be in the form of concentric circle which is having less diameter. But as the distance of a wire that increases from the center, then the line will make a kind of an arc, because it is still further on. If you will focus, so we can extend it and we can see that the line is just going to make in this way. The pattern will, we can assume, we can imagine the pattern of magnetic field line of force maybe in this way we can conclude. So at the center they will just pass on over the straight line, and at individual all the points they are just going to show a pattern of concentric circles. These are for today's everybody. So these are the points. I hope that you like this, and I hope that all the topics whichever I have just covered today, that is clear in your mind. But still, if you are having some queries and doubts, just please mention it in your comment box. And thank you for watching the video.